Okay, let's try number 5. They give you this equation, and they tell you that this between negative 2 pi for x is less than 2 pi. And they want you to find, in part A, they want you to find the derivative of dy dx. So let's take the derivative of both sides. We have secant squared y dy dx equals 1 plus 1 dy dx. And just group your dy dx's. Get 1. Factor out the dy dx. You'll get secant squared of y minus 1. The dy dx is equal to 1 over secant squared y minus 1. And when you see this one right here, this might help you out a little bit if you remember your Pythagorean's identities. Sine squared plus cosine squared equal to 1. But this is in terms of secant squared, so secant is 1 over cosine. But if you divide through this original Pythagorean by cosine squared, you're going to get secant squared 1. Sine over cosine would be tangent squared. So secant squared minus 1 is equal to tangent squared. So this might end up helping you in the long run. 1 over tangent squared. Alright? So that's part A. And they want you to find the x and the y coordinates at each point where the tangent line to the graph is vertical. Well, part B, one way to think about this is to rewrite it. Switch colors and do it over here. Tangent squared can be written as sine squared over cosine squared. So since this is part of a fraction, 1 over tangent squared can just be written as cosine squared over sine squared. And since we're talking about part B, we want to know the tangent line of the graph is vertical. So vertical tangent lines, of course, occur when the denominator is equal to 0. So sine squared, or just sine in general, does what? Starts off at 0. Goes back down. So if you have sine of the angle squared, when it's 0, 0 squared is still 0. So all you have to do is remember back talk about where it's equal to 0. Of course, that's pi, and that's 2 pi. 2 pi is outside of our range. It has to be less than 2 pi, not equal to 2 pi. And then, let's see. Just remembering that the goes back around on the negative side. And this occurs at negative pi, and it reaches the x-axis again at negative 2 pi. So that should help you a little bit, just to be able to word that properly. Since I want you to know the x and the y coordinates, what are you going to do? Let's take a look at a situation where it's pi. So we're going to have 3 answers for part. When it's pi, what are you going to do? You're going to have tangent of y equal to 0 plus y. Well, let's recall that this is y, okay? So we already found y, now we're trying to find x. So back into the original equation, we're going to have the tangent of pi is equal to x plus pi, and now we're going to find the x value. So this was a little bit different because we're so used to solving for plugging into x. So just recall back what is the tangent of pi. It's tangent of sine over cosine. Pi at sine equals 0. That's 0 x plus pi. So at pi, it's actually a negative pi. X would equal negative pi. So it's a little bit tricky there. But once you do the first one, then you just have to find the value at 0 and at negative pi. All right. And on part C, they want you to find the second derivative. And recall that this is what we found first. So another way of thinking about this is first derivative equal to 1 over tangent squared. But 1 over tangent squared is the same thing as cotangent squared. And it was in terms of y. So, this is dy dx. As we take the second derivative with respect to x. And we'll go ahead and do this one. Well, what's the derivative of tangent? Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. But we don't just have cotangent. We have this function squared, right? So it's sometimes helpful to rewrite it in terms of this. So now you can see that we have the chain rule, right? So the chain rule says find the second derivative to be 2 times cotangent to the first power times the derivative of the inside, which we found to be negative cosecant squared of y, right? And we just took the derivative with respect to y, so we write a dy dx. And that equals second derivative with respect to x. All right. What do you do with this? dy dx. Well, you know what dy dx is equal to because you just had it written here. So we can substitute that in. So we have 2 cotangent y. Put our negative out here if we want. This is cosecant y squared. And dy dx is 1 over tangent squared in terms of y. So you might possibly be able to leave it like this, but I think we could probably clean this up quite a bit. Let's see. So cosecant is what? 1 over sine, so we have 1 over sine squared. Cotangent is cosine, all in terms of y, over sine. And 1 over tangent squared, cosine squared over y, sine squared. So it looks like we have all signs on the bottom. And so since it's all being multiplied, we have sine to the 5th power at the bottom. And on top we have cosine y to the 3rd power. And we still have our -2 out in front. So what do we do with this? Cosine to the 3rd, we have sine to the 5th on the bottom. So we could say that we have cotangent cubed of y. And we have an extra 2 sine on the bottom. So that would be cosecant squared. Okay. So hopefully that'll help you out a little bit. And provided I didn't make a mistake in my algebra on this last part, should be close to the right answer. Okay.